Hi students, in this video we are going to learn two more theorems of the chapter circles and cyclic quadrilateral. Okay, these theorems are also very much important. Okay, you should be equally knowing these theorems. See, you should be knowing the proof as well as how to apply the theorem as well, because before knowing the theorem you will be not able to solve a problem. Understood? So let us see the theorem. What does the theorem 3 says? Equal chords are equidistant from the center of the circle. What does the theorem says? Equal chords are equidistant from the center of the circle. First, always know the meaning of what is the distance of chord from the center. First you should be knowing the meaning of distance of the chord from the center. Okay, so let me consider one circle. With center O. Let me consider a circle with center O. Now let AB be the chord. Let AB be the chord. Now understand what is the meaning of distance of chord from the center. See, pay attention. If you are drawing some random line like this, you can't call this as a OP is a distance of a chord from the center. You can't tell like this, or else you can't draw a straight line like this slant line like this, and you can call some OQ. This OQ is the center distance of a chord from the center. You can't tell like that. So always you should remember one thing: the distance between the center and the chord will be a perpendicular distance. Understood? I'll erase this one. So always, what is the meaning of distance between center and the chord? It should always be a perpendicular distance. Understood? So what is the meaning of distance between the center and the chord, which is nothing but a perpendicular distance? Is that clear? So I'll erase this P and Q. So this OP will be the distance from center to the chord. It will always be a perpendicular distance. Understood the meaning of distance between the center and the chord? This will be always perpendicular to the chord. You cannot draw simply a random line like this and you can call it as a distance from center to the chord, which is completely wrong. What is the meaning of distance from center to the chord? Which will always be a perpendicular distance. Understood? Now what they are telling, equal chords are equidistant from the center of the circle. Let me consider one circle. Now let us do the proof. Okay, before moving on to proof, first understand the meaning of the theorem. What they are telling, equal chords are equidistant from the center of the circle. So I should consider two chords. See, this is not restricted only to one or two chords. It can be implemented for multiple chords also, but right now I am taking example for only two chords. Understood? So let AB and CD be the two equal chords. What they are telling, AB and CD are two equal chords. Equal chords are equidistant from the center of the circle. So what they are telling, if AB is equal to CD, then what's the result? Then their distance from the center will be equal. Now what is the distance from the center to the chord? It should be a perpendicular distance always. Understood? It should be a perpendicular distance. So what is the result? If I call this as OP, this OP will be equal to OQ. Understood? If AB is equal to CD, if chords are of equal length, then the distance from the center will be equal. Then what's the result? OP will be equal to OQ. Understood? So let me take one more diagram. Okay, let me take one more diagram and explain the concept. First, write down this short note. If the distance of the if the lengths of the chords are equal, then their distance from the center will be equal. If AB is equal to CD, then OP will be equal to OQ. Let me take one more example. In this case, I'll consider 3 equal chords. So it is applicable for 2, 3, 4 multiple chords also. I'll consider 3 equal chords. Understood? Just pay attention here. So here chord AB is equal to chord CD, which is equal to chord EF. So I am considering three equal chords. Whether the theorem holds good? Yes, obviously the theorem holds good. Now draw the perpendicular distance from the center to the chord. Let O be the center of the circle. So what will be the distance between center and the chord? So if I join like this perpendicular length will be the distance from center to the chord. This perpendicular length will be the distance from center to the chord. So for three chords I have to draw three perpendiculars. Okay, for three chords I have to draw three perpendiculars. Okay, so for three chords I am drawing three perpendiculars. PQ, I'll consider this as R. So how you'll apply the theorem? They have given three equal chords. Means if AB is equal to CD is equal to EF, means all three chords are of equal length, then what's the result? Then OP will be equal to, means the length of this OP, distance from center to the chord, OP will be equal to OQ will be equal to OR. Understood? Don't be in a misconception that always it should be applicable for two chords. No, it can be applicable for two or more chords as well. What does the theorem says? Equal chords are equidistant from the center of the circle. Means if three equal chords are given, means AB is equal to CD is equal to EF, then what's the result? OP will be equal to OQ will be equal to OR. Is that clear? Please make a note of this one before moving on to proof. Okay, now we'll move on to proof. I'll erase this one. Now we'll move on to proof. So just recall what are the parts of theorem. So it will be given to prove. If construction is there, means construction, then we'll write the proof. Okay, now first what is given? Write down the given. Given is what? O is a circle with center O. A circle with center O. Next, what they have given? A circle with center O. Next, chord AB is equal to CD. These are the data they have given. Equal chords are given. Given is what? A circle with center O and AB is equal to CD. What they are asking us to prove? Then the distance from center to the chords will be equal, means OP will be equal to OQ. OP will be equal to OQ. Is there any construction? Yes, we have construction. What's the construction? So, what's the construction? Draw radius, means you can join OA and OC. Join OA and OC. What is my construction? My construction will be join OA and OC. What will be my construction? Join OA and OC. Now how we are going to prove the theorem? Again the same thing, we will be using the concept of congruency. We will be proving using the concept of congruency. Between which two triangles I have to prove the congruency? Between these two triangles I have to prove the congruency. So now we'll move on to proof. So what's the first step of proof? I have to consider the triangle. So in triangle COQ, and triangle AOP, in triangle COQ and triangle AOP. Okay, which two triangles I am considering? In triangle COQ and triangle AOP. You can ask, sir, can I write it as QCO? Yes, obviously you can write it as QCO also, not a problem. Now how we are going to prove the congruency? See, mark this as 90 degree. Okay, now how we are going to prove the congruency? For this we will be using the first theorem as well. See, he has given what is given? AB is equal to CD, means chords are of equal length. AB is equal to CD he has given, means this length AB is equal to CD. Now you want to get CQ, okay, or you want to get AP. From AB, if you want to get AP, means what you have to do? From AB, if you want to get AP, means what you have to do? You have to divide 2 on both sides. So AB by 2 is equal to CD by 2. AB by 2 is equal to CD by 2. What I am doing? Divide divide 2 on both side. What I am doing? Dividing 2 on both side. Why I am dividing it by 2? See, from CD, from the entire length CD, if I want to get just CQ means I have to divide it by 2. Similarly, from the entire length AB, if I want to get AP means I have to divide it by 2. Now, what is AB by 2? AB by 2 is nothing but AP. Now, what is AB by 2? AB by 2 is nothing but AP is equal to, now just observe what is CD by 2. What is CD by 2? CD by 2 is nothing but CQ. You can ask, sir, CD by 2 I can write it as QD. Yes, obviously QD will also be a correct answer. But for this triangle, we don't need the side QD, right? Why we want to need the side QD, which is not required. That's why CD by 2 I am writing it as CQ. CD by 2 I am writing it as CQ. So what I got? AP is equal to CQ. One side I got. Here you have to write theorem 1. Theorem 1. Here you have to write theorem 1. What does the theorem say, sir? A line segment drawn from center perpendicular to the chord bisects the chord. You write the entire statement here. What does the theorem 1 says? A line segment drawn from center perpendicular to the chord bisects the chord. Clear? So what I got? I got AP is equal to CQ. Next, if I observe, we have one is 90 degree. Angle Q is equal to angle P is equal to 90 degrees. So both are right angle triangles. So you mention that also. Angle CQO is equal to APO is equal to 90 degree. Angle CQO is equal to angle APO is equal to 90 degree. Understood? Which is given because the distance from center to the chord will always be a perpendicular distance. Okay. Angle CQO is equal to APO is equal to 90 degree. Can I get one more side? Yes. OC is equal to OA. Reason? Radius of the same circle. OC is equal to OA. What's the reason? Radius of the same circle. Now just tell me by which criteria these two triangles are congruent. See, both are right angle triangle. I showed CQ is equal to AP, which is a perpendicular distance, and CO is equal to AO, which is hypotenuse. So yes, it's by RHS criteria. Therefore, triangle, now be careful, and triangle COQ, for C which angle is equal? A is equal. Okay, AOP, you have to write it as COQ. Triangle COQ is congruent to triangle AOP. Okay, triangle COQ, just observe the triangle COQ is congruent to AOP by which criteria? By RHS criteria. Once you prove the congruency, what's the result? Okay, so you already prove the congruency of these two triangles, so you can easily tell OP is equal to OQ. Okay, you can easily tell OP this length OP will be equal to OQ, which is a CPCT. Just write down the conclusion. OP will be equal to OQ. Okay, which is a CPCT. Okay, OP will be equal to OQ, which is a CPCT. Hence, it is proved. Just write down the theorem. See, here you have to remember one thing. Okay, given is what? See, both are right angle triangle, that you will easily identify. Next, CO is equal to AO, that also you will identify, but one more side you will not get. Okay, why? Because they have given CD is equal to AB. What they have given? Chords are of equal length. CD is equal to AB. From CD, if you want to get CQ means what you have to do? Divide 2. From AB, if you want to get AP means what you have to do? Divide 2. That's why this operation is very much important. Pay attention. Here this is given. Okay, AB is equal to CD. This is given. Chords are of equal length. Next, what you have to do? Divide 2 on both sides. Now AB by 2, what can you write? AP. CD by 2, what can you write? CQ. Understood? And you have to mention the reason here, because see here AB by 2, how can I write it is CQ? Because from first theorem, what does the first theorem says? A line segment drawn from center perpendicular to the chord bisects the chord. With the help of that theorem theorem only, AB by 2 I can write it as AP. Is that clear? So you have to mention the reason here, theorem, but you don't write it as theorem 1. You write the entire definition. What does the definition says? A line segment drawn from center perpendicular to the chord bisects the chord. Okay, just go through the theorem once again. Now let us move on to theorem 4. See, theorem 4 is nothing but converse of the theorem 3. Now what does the theorem 4 says? If chords are equidistant from the center, if chords are equidistant from the center, then chords are equal. First try to understand what does the theorem says. What they are telling, if chords are equidistant from the center, so I'll consider two chords. Okay, let AB and CD be two chords. If chords are equidistant from the center, let O be the center, what they have given, if chords are equidistant, so what is the distance from center to the chord? It will always be a perpendicular distance. Okay, so it will always be a perpendicular distance. So now what they are telling, if chords are equidistant from center, if chords are equidistant from center, means they are telling OP is equal to OQ. If chords are equidistant from center, then chords are equal. Okay, so try to make a short note. If, what does it says? If chords are equidistant from the center, so what does it mean? OP is equal to OQ. Okay, if OP is equal to OQ, then what's the result? Then chords are equal. Then chords are equal means AB is equal to CD. Okay, what does the theorem says? If chords are equidistant from the center, then chords are equal. Try to apply the theorem. If OP is equal to OQ, then AB is equal to CD. Okay, this theorem also, it is not restricted only to two chords. Understood? It can be applicable for multiple chords as well. So let me consider three chords here. Okay, you can frame an example for four chords as well. The property will holds good. Okay, now what they are telling, if chords are equidistant from the center, if chords are equidistant from the center, then chords will be of same length. So let me consider three chords. I'll consider this as AB. Okay, I'll join this line. Let this be CD and let this be EF. Okay, let O be the center. So always this length will be perpendicular. OP, OQ and OR. Understood? So try to write the short note. How can you write? If, okay, if chords are equidistant, means length of OP will be equal to OQ will be equal to OR. Okay, then what's the result? Then chords will be of same length. Then AB will be equal to CD will be equal to EF. Understood? Don't restrict yourself only to two chords. Understood? Because the theorem is applicable for even two or more chords as well. So you have to pay attention on the concept rather than mugging up. Understood? So now I'll erase, if you have made a note means I'll erase this one. Let us move on to proof. Let us move on to proof of the theorem. So you make a short note. If A is OP is equal to OQ, then AB is equal to CD. So this will be your short note. Okay, you should be knowing the theorem as well as you should be knowing how to make a short note. Okay, now let us move on to proof. What's the first thing I have to do? So I have to write the given. So what is given? Okay, so what is given? If chords are equidistant from the center, means, okay, you write the same thing. Let O be the a circle with center O. A circle with center O. Okay, next what they have given, OP is equal to OQ. They are equidistant from the center. OP is equal to OQ they have given. What they are asking us to prove? To prove what? to prove AB is equal to CD. To prove AB is equal to CD. What is my construction? What is my construction? Same. You have to just join OA and OC. Okay. What is my construction? Join OA and OC. Understood? Now let us move on to proof. I'll write the proof on the right side so that you can refer the diagram as well. So let us move on to proof. So proof, what's the first step? For which two triangles I have to prove the congruency? Same. In triangle AOQ and triangle COP. In triangle AOQ and triangle COP. Okay. In triangle AOQ and triangle COP. Okay. So first, okay, this is 90 degrees. See, I forgot here also. So both are right angle triangle. So in right angle triangle, I can say that AO is equal to CO, which is a radius of a same circle. Next, OQ is equal to OP. They have only given. So directly it's by RHS criteria. So angle AQO is equal to angle CPO is equal to how much? 90 degree. Okay, which is given. Why indirectly they have given? Distance from center to the chord means it will always be a perpendicular distance. Understood? Next, OA is equal to OC. Reason is what? Radius of the same circle. Radius of the same circle. Next to OP is equal to OQ, they have given. OP is equal to OQ. If you observe here only they have given. OP is equal to OQ, which is given. Understood? So by which criteria? Therefore triangle AOQ, yeah, just you match and write AOQ is congruent to triangle. For A, which angle is equal? C. Okay, C. For O will only be equal. CO left out is P. AOQ is congruent to triangle COP by which criteria? By RHS criteria. Understood? By RHS criteria. Once you prove the congruency, what will be your CPCT? Pay attention here. This AQ is equal to CP will be your CPCT. AQ is equal to CP. This will be your what? CPCT, corresponding parts of congruent triangle. Now pay attention. From AQ, if you want to get AB means what you have to do? See, from AQ, if you want to get AB means what you have to do? You have to multiply 2. Okay, multiply 2 on both side. Okay, multiply 2 on both side. Understood? See, you should be knowing the concept. Don't just memorize multiply 2 on both side. No, you should be knowing why you are multiplying 2. See, you got here AQ. From AQ, if you want to get AB means what? We know AQ is twice the length AB. So you have to multiply 2 on both side. So 2 times AQ is equal to 2 times CP. Okay, so you have to multiply 2 on both side. 2 times AQ is equal to 2 times CP. Now what is 2 times AQ? 2 times AQ is nothing but AB. 2 times AQ is nothing but AB. What is 2 times CP? 2 times is CP is nothing but CD. Okay, hence proved. But here you have to write the reason, which is theorem 1. What does the theorem say? Theorem 1 says a line segment drawn from center perpendicular to the chord bisects the chord. You have to write the reason here. So I got AQ is equal to CP as my CPCT. From AQ, if I want to get AB means what I have to do? I have to multiply 2. So I have to multiply 2 on both sides. Now what is 2 times AQ? 2 times AQ is nothing but AB. What is 2 times CP? 2 times CP is nothing but CD. So hence the theorem is proved. I hope these two theorems is also clear. Just make a note of the entire theorem and you practice it once or twice, then you will get a clarity. Is that clear?